The solenoid bore, when using it as for repulsive magnetics, the diamagnetic, it can only be one diamagnetic solenoid coil. Actually, it could actually be two, forgive me. There could be two diamagnetic coils, but only one iron ferromagnetic. It can only be used when using repulsive force. It works the same way as the right-hand rule and the Lenz's law of force, which is actually a phase point in for repulsion, which is counterclockwise. And clockwise is the pull force as to magnetize and cause it to move in the opposite direction, which is clockwise. Now, when using two solenoids against one another as this electromagnet, there can only be one iron core to use as a Hall effect, the only iron core, because of the magnetization. When synchronizing with another Hall effect coil, it will cause it to repulsive wave. When having two electromagnets together, it changes the ferromagnetic polarization to where the top end may become, due to the phase point of the electrical energy winding, the front node may become the north polar, and the end may become the south polar. But no matter where you phase the wire, no matter what part you charge it in, counter or clockwise, it will magnetize with two bores. But when there's only one bore, it causes the one inheriting the bore to move away from the coil that does not have the bore. When taking two permanent magnets and using it on its opposite polarization and placing two pieces of metal between the two magnets polarization, the magnetization shall not stick, but the magnetized ferromagnetic metal shall change its polar. So if the phase point of the junction of the permanent magnet to the ferromagnetic iron solid, the phase point may change the other side or the six sides to a different polarization of a block iron when being phased or magnetized by a permanent magnet, so that it will become common and not attract together when there is two pieces of separate metal between two permanent magnets.